Okay, we are continuing on with this 6-4 lesson. So you're learning how to factor something new today, but you kind of already know what to do. It's just got a little bit of something new. All right, so one thing I want you to notice is the first several problems, the exponents go 4, 2, constant, 4, 2, constant, 4, 2, constant, 4, 2, constant. Well, our normal A times C rooftop typically looks like this. It has an x squared, then an x, and then a constant. The exponents go 2, 1, constant. Well, these are similar, but instead of 2, 1, constant, it's 4, 2, constant, 4, 2, constant. So we're going to factor these like we know how to do with our A times C rooftop, but there's going to be a twist. Okay, so this first page, all we're going to do is factor. We're not going to solve. We'll solve on the next page. Okay, so here we go. Exponents, 4, 2, constant. So we're going to A times C rooftop with a twist. So A times C, 1 times 6 is 6. And I want the numbers to add to make 7. So do you know who multiplies to make 6 and adds to make 7? 6 times 1. 6 times 1 is 6. 6 plus 1 is 7. Okay, because it's the easy one, we got to go straight to the parentheses. The numbers we found go in the back. So positive 6 goes in the back. Positive 1 goes in the back. And before, the letter we worked with, x, went in the front. And that's what we did, and we were done. However, we have a twist we can't forget about. X times x only makes x squared, and I'm trying to get x to the 4th. So this needs to be x squared, and this needs to be x squared. That way, x squared times x squared makes x to the 4th. And that's the twist. Now, sometimes, because now we have even exponents and they're two terms, 1, 2, 1, 2, they could be a difference of squares. So we have to look to see if either are a difference of squares. That's not, there's no minus, and that's not, there's no minus. Okay, so that's my answer. Okay, let's look at the next one. Exponents, 4, 2, constant. So I'm going to A times C rooftop with a twist. So A times C, 1 times negative 10, that's negative 10. And we want the numbers to add to make negative 3. Okay, do you know what two numbers multiply to make negative 10 and add to make negative 3? Negative 5 times 2. Negative 5 times 2 is negative 10, and negative 5 plus 2 is negative 3. Okay, so I'm going to build my two sets of parentheses. The numbers I found, because it's the easy one, go in the back. So minus 5 plus 2. But instead of x and x, it's x squared and x squared. Now let's see if either of them are a difference of squares. This one's got a minus, but is 5 a perfect square? No. Is that one a difference of squares? Nope, there's not even a minus. And they're not a sum or a difference of cubes, which we learned about in the last lesson, because the exponents aren't multiples of 3. Plus, those are not perfect cubes. Okay, let's try another one. So this one, my exponents go 4, 2, constant. So I'm going to A times C rooftop. 1 times negative 27 makes negative 27. And you want the numbers to add to make negative 6. So do you know what multiplies to make negative 27 and adds to make negative 6? Negative 9 and positive 3. Okay, so let's try factoring it. What do you think it is? X squared minus 9 and x squared plus 3. Yeah. Now let's see if either of these are a difference of squares. That guy is, he's got a minus, even exponent, and 9's a perfect square. Well, if you forgot, a difference of squares always factors with two sets of parentheses, one with a plus, one with a minus. And then you put the square roots in. What's the square root of x squared? X, because x times x is x squared. And what's the square root of 9? 3, because 3 times 3 is 9. Now, is this guy a difference of squares? Nope, so just recopy him. And that's my answer. Completely factored. Okay, let's try it again. 4, 2, constant. So a times c rooftop with a twist. What's a times c? 1 times 4 is 4. And you want the numbers to add to make -5. So what two numbers multiply to make 4 and add to make -5? -4 and -1. And it's the easy one. So build your two sets of parentheses, and it's x squared minus 4 and x squared minus 1. Okay, what about these guys? Are either of these guys a difference of squares? They both are. That's a minus, even exponent, 4 is a perfect square. That's a minus, even exponent, and 1's a perfect square. Okay, so both of these are going to factor with two sets of parentheses, one with the plus, one with the minus. Two sets of parentheses, one with the plus, one with the minus. And then I'm going to put the square roots in. So what is the square root of x squared? X, because x times x is x squared. And what's the square root of 4? 2, because 2 times 2 is 4. Okay, for the one in the back, what's the square root of x squared? X. And what's the square root of 1? 1. And that's my answer. This one completely factored out, as simple as it could get. Now, number 5 looks different. The exponents do not go 4, 2, constant. I only have two terms, 1, 2. So remember, first you look for a GCF, and I haven't looked for a GCF the whole time today, and that's because it's a 1 in front, so there will never be a GCF if it's a 1 in front unless they all have x's. So this does not have a GCF. Then you look to see if it's a difference of squares, and then you could look to see if it's a difference or sum of cubes, which is the latest thing that we learned. So which of those things do you think it is? It's a difference of squares. It's got an even exponent, a minus, and 81's a perfect square. Okay, so I'm going to build my two sets of parentheses, one with a plus, one with a minus, and then I'm going to put in my square roots. What's the square root of x to the 4th? X squared, because x squared times x squared is x to the 4th. And what's the square root of 81? 9, because 9 times 9 is 81. Now, do you think that's my final answer? Nope, because this guy is a difference of squares. This one's not because it's a plus, but this is a minus and even exponent, and 9's a perfect square. So this one right here is going to factor with two sets of parentheses. I'm going to come where I got more room. I'm so sorry. So I'm going to come down here where I have a little more space. One gets a plus, one gets a minus. What's the square root of x squared? X, because x times x is x squared. And what's the square root of 9? 3, because 3 times 3 is 9. And then this guy does not factor, but I need to drop him down. So x squared plus 9. And now it's fully factored. And so this problem was a difference of squares with another difference of squares within it. Okay, so far all we've done is is factor. Now we're going to solve. But this is way easier than the last lesson. I will not have to use quadratic formula on these, and I'll explain why in a second. Okay, so to solve, we need to make sure they say equals 0 before we begin. So what do you notice about number 1? It does not say equals 0. So I am going to have to move this 12 by subtracting it. So the left side will now say x to the 4th minus x squared minus 12 equals 0. And now it's like what we were practicing on the previous page. The exponents go 4, 2, constant. So it's a times c rooftop with a twist. And it's the easy one. What's a times c? Negative 12. What do we want the numbers to add to make? Negative 1. That's the number in front. So what two numbers multiply to make negative 12 and add to make negative 1? Negative 4 times positive 3. Okay, remember it's with the twist. So it's x squared with a minus 4. And it's x squared with a plus 3. Now let's see if I can keep going. Are either of these a difference of squares? Yeah, that guy is. He's got a minus, even exponent, and 4 is a perfect square. Okay, so he's going to factor with two sets of parentheses, one with a plus, one with a minus. Now let's put in the square roots. What's the square root of x squared? X. And what's the square root of 4? 2. Now this guy is not a difference of squares, so just drop him. So this is where we stopped on the front page. But this page I'm solving. One, because they told me to solve in the directions, and two, there's an equals, which means I want to solve. So I'm going to set this equal to 0, and I'm going to solve. Now, some of this we've done before. If you took this first factor, x plus 2, and set it equal to 0, what would you get if you solved that equation? Negative 2. You would get rid of addition of 2 by subtracting, so you get negative 2. Okay, now what do you get if you set this factor, x minus 2, equal to 0? You get a positive 2, because you get rid of subtraction of 2 by doing the opposite and adding, so you get a positive 2. So here's two answers. Do you know how many answers I'm going to have when I'm done? I'm going to have 4 answers because the highest exponent is a 4. So I've got 2 of them. Now I need to find the other 2. So now I'm going to take my third factor, x squared plus 3, and set it equal to 0. Now the reason I don't have to use quadratic formula is because it doesn't have just a plain x. It's got an x squared and a constant, but not just a plain x. So I can solve this with the square root method. Your goal is to get x squared by itself and then square root. We've done this before. So to get rid of addition of 3, we do the opposite and subtract. So then the x squared comes down. 0 minus 3 is negative 3. And then to get rid of a squared, we square root both sides. We slap down our plus minus. Who takes the negative out? I does. And then you're left with a positive square root of 3. Now, if you could take the square root of 3 or break it down, you would, but you can't. And these are your remaining 2 answers. One answer is a positive I square root of 3, and the other answer is the negative I square root of 3. So if you forget to slap down your plus minus, then you won't have 4 answers when you're done. So just remember, if the highest exponent is 4, you need 4 total answers. 1, 2, 3, 4. And that's how you solve one of these. So much better than a sum or a difference of cubes, because you have to use quadratic formula with that. Okay, let's look at number 2. All right, it already says equals 0, so I'm good to go there. Now I notice the exponents go 4, 2, constant. So I'm going to a times c rooftop with a twist. And it's the easy one. What's a times c here? 1 times 18, that's 18. You want the numbers to add to make 11. So what 2 numbers multiply to make 18 and add to make 11? 9 times 2. 9 times 2 is 18. 9 plus 2 is 11. Okay, it's the easy one with a twist.